looking at worksheet number 24 here this morning. We're going to go over 4 questions, 5, 6, 9, and 10. Starting with number 5. It says, how far from the center of the Earth is the gravitational field strength? 8.0 newtons per kilogram. Some people are really good at reading the question and identifying whether you've got a producer or an experiencer and therefore which equation to use. Some people aren't so good at it, and that's okay. If you're not so good at it, then draw a diagram, because sometimes that becomes a little bit helpful. If we draw a diagram, this is the Earth. We're looking for the field strength somewhere up here, a certain distance from the center of the Earth. Now, you know the mass of the Earth, right? It's 5.97 or 5.98, depending upon which version of that number you're using, times 10 to the 24 kilograms. You know the mass of the Earth. Is the Earth a producer or experiencer here? Is the Earth causing the field at that distance above its surface, or is it experiencing that field? What is it, Nate? It's producing the field. We know nothing about this point right here, where we're trying to find the field. We don't know if there's an experiencer there or not. If there is an experiencer there, we know nothing about it. So the only thing we know something about is the producer. Let's use the producer equation. G is equal to big G m over r squared. Big G is 6.67 times 10 to the negative 11. By the way, yesterday as I was walking around when you guys were working on these questions in class, I saw some people kind of shortcutting it or kind of cheating a little bit, saying G is equal to, or little g, gm over r squared. Be careful with that, okay? Be careful. Okay, the gravitational field strength is little g. The gravitational constant is big G. If you start calling them the wrong thing, little g where it's supposed to be big G or big G where it's supposed to be little g, then you're bound to, at some point, fill in a wrong number, which is going to give you a wrong answer. So call it the right thing. Okay, it gives us a better chance of getting the right answer. The mass here is the mass of the Earth. The mass of the producer is 5.97 times 10 to the 24 kilograms, or 5.98, depending upon which version you're using. Oh, sorry. We got to rearrange this, don't we? We're solving for r, the distance from the center of the Earth. So let's say, take the r squared up by multiplying. G times r squared is equal to G over m. G times m. R squared is equal to G times m divided by G. Take the little g over by dividing, and then we're going to square root all that. G times m over little g. So this is 6.67 times 10 to the negative 11 times the mass of the Earth, 5.97 or 5.98 times 10 to the 24 kilograms, and G is 8.00 newtons per kilogram in this case. Can we do the math on that one? And it works out to be 7.06 times 10 to the 6 meters. We don't have to do anything with the radius of the Earth here. We don't have to add it. We don't have to subtract it here. How come? Some of the questions we did, right? Some of the questions we had to add the radius of the Earth. Some of the questions, like the next one, you're going to have to subtract the radius of the Earth. Why don't we not have to worry about that here? Yep. Yeah, we're asked to find the distance from the center of the Earth. And r represents the distance from the center of the Earth. If you were asked to find the distance above the surface, like you are in question number 6, then you're going to have to subtract the radius of the Earth. But that's not the case here. So look at each question, read the question, answer the question according to what you're actually being asked. Is that okay, everyone? Yep. Okay, let's take a look at number 6 now. How far from the surface of the Earth is the gravitational field strength? 7.50 meters per second squared. It's almost the same question. We're going to use the same equation. It becomes r is equal to gm over little g. Right, the Earth is the producer. Again, we know something about the Earth, so we'll use the producer equation, which is little g is equal to gm times gm over r squared. Exact same equation we used in number 5. We rearrange it, get the exact same form here. We sub our numbers in. 6.67 times 10 to the negative 11 times the mass of the Earth, once again, is 5.97 or 5.98. Divide that by little g, which this time is 7.50. We square root that. We get a value here of 7286508.08 meters. That's pretty precise, eh? To the nearest centimeter. Well, that's why if this was a final answer, that's why we round it, right? It doesn't make any sense to calculate this to the nearest centimeter, right? But we're going to use the unrounded number until we get a final answer here. What is our final answer? This represents the distance from the center of the Earth. What are we looking for? The distance above the surface. So what do we got to do here? Add the radius of the Earth? Yeah. Josh, you're right. If we have this distance, if we just calculated this distance, but yet we want to find this distance, then we're going to subtract this minus this, the radius of the Earth, to get what we're looking for, the distance above the surface. So let's subtract the radius of the Earth, which is 6.37 or 6.38 times 10 to the 6 meters, whatever version you used. Okay, that gives us a value of 9.12 times 10 to the 5 meters. Now let's have a look at number 9. Number 9 says, calculate or determine the gravitational field strength experienced by a 50 kilogram object that weighs 400 newtons. Look, there's a word in there that is key to this, right? Key to telling us what's going on here. What is that key word? Experienced, right? Determine the gravitational field experienced by a 50 kilogram object that weighs this much. We don't know what causes this field. Maybe it's the Earth that causes this field. Maybe it's something else that causes this field. Guess what? It doesn't matter. It doesn't matter what causes this field. Okay, we know something about the experiencer. Let's use the experiencer equation. Let's write down our givens first for this, though. 50.0 kilograms is our mass. What is this 400 newtons thing, the weight? What does the weight correspond to? Yep. It's the force of gravity, right? Which is, of course, m times g. Now, we're looking for the field strength, so we're going to say little g is equal to F over m, the experiencer equation. F is 400 newtons divided by the mass of 50.0 kilograms. And we're going to say that 400 divided by 50 is 8.0, I think it is, yeah. 8.00 newtons per kilogram. Or you could have said 8.00 meters per second squared. So this is probably near the surface of the Earth, and the Earth is probably the producer here, given the value that we get for field strength. Okay, but in the end, not necessarily. We don't know for sure what causes this field. So we use the experiencer equation. 10. 10's a good question. 10 says, determine the field strength experienced by a 25 kilogram object that weighs 175, and then how far above the Earth's surface does this object experience this field? The first part of this question, we'll focus on that first. This 25 kilogram object is an experiencer, so let's find the field strength experienced by this object. We're going to say it's F over m. It's 175, the force of gravity, or the weight, divided by 25. And that gives us a value of, what is it, 70? 7.0? 7.0 newtons per kilogram. Okay, there's the field strength that this thing experiences. Now, how far above the Earth's surface does it experience it? Now, in the second part of this question, the Earth is the producer, right? Let's use the producer equation now for the second part of this question. G is equal to gm over r squared. Now we want to find a distance, so let's rearrange this to solve for r. The r squared goes up, g goes down. Right, we multiply by r squared, we divide by little g, and then r becomes equal to the square root of g times m over little g. Big G is 6.67 times 10 to the negative 11. The mass of the Earth is 5.97 times 10 to the 24 kilograms, or you could have used 5.98. Little g is, oh, wait a second, what's little g? 9.81? What's little g? Yeah. Yeah, this object experiences a field strength of 7 newtons per kilogram. We had to use the experiencer equation because that's all we knew about in the first part of the question. But we know what causes that field, right? It was the Earth that caused that field. So let's use the producer equation to solve for r, given the field that it produced at that point, 7.0 newtons per kilogram. So take the value for the first part, use it for the second part. That gives us a value of 754,225.411 meters. But that's not our final answer. What are we going to do to find our final answer? Yep. Yeah, this is the distance from the center of the Earth, right? Okay, if we want this distance, then we have to subtract this one minus this one gives me this one. So subtract the radius of the Earth, 6.37 or 6.38, we end up getting 1.2 times 10 to the 6 meters above the surface of the Earth.